Hello guys! In this video we will create a day and night cycle, but not in a common way most YouTube tutorials do. We won't be using BP Sky Sphere. Instead, we will use Sky Atmosphere, the feature that came in a version 4.24. Also, we will include Skylight and high exponential fog, so our day and night cycle will be more realistic. Also, I will include subtitles to only those parts which are hard to understand without text explanation. So let's begin. First of all, let's go inside our blueprints folder. Next, in our common folder. Here we need to create a new folder and call it weather system. It might be a little bit confusing, but day and night cycle is just a little piece of a big system which we will create during our tutorial series. Next, let's go inside our weather system folder and create a blueprint class. We need to choose actor because our weather system will be located inside our level. Let's rename our blueprint to BP weather system. Just so simple. Now let's open our weather system blueprint. First of all, let's go into our event graph and delete the default nodes. Next, let's go to the construction script. For our weather system, we need to create, for this moment, only 4 variables which will represent a real-world actors. They are directional light, skylight, sky atmosphere, and exponential high fog. Let's create them. The first one will be directional light. Name it as you like. I'll go with sun. Change its type to directional light. As you can see, we have 2 options, but we don't need a component, we need an actor. Also, make sure to check an attribute called instance editable, so we can provide a reference to our real-world actors for our variables. Let's create the rest of our variables. Skylight. Sky atmosphere. High exponential fog, or just fog. Check everything. Now compile and save. To visualize the basic setup of our weather system, we need to use the construction script. So, because of this reason, we need to duplicate some functions which we create in the event graph to our construction script. The basic idea behind day and night cycle is to rotate the directional light on its y-axis. The y-axis stands for sunset and sunrise locations. Also, we can define from which side of our scene the sun will appear. So basically, we need to adjust only two axes, the y-axis and z-axis. Before we start, we need to create a folder which will store some curves. These curves will define our weather system behavior. The reason why we choose curves is that the curve is much more flexible to adjust. So let's head back to our content browser, and in our weather system folder we need to create a new folder. Let's name it curves. Next, go inside our newly created folder and let's create a curve which will define our day length. Right click, search for miscellaneous, expand the category and look for curve. Select it and select curve float. Let's rename it to C underscore day length. Now, let me explain one thing. The transform for any actor in Unreal Engine works with negative and positive values. So rotation is measured from negative 180 to positive 180 degrees. As we know, we move around the sun in one direction. So I'd like to propose my approach. We will accumulate the positive values and withdraw negative values. 0, 90, 180, 270, 360, 450 degrees, and so on. I think my approach is less confusing. I hope you understand the basic idea. Now, let's open our day length curve and make some changes. Here we can see a graph where x-axis represents our time and y-axis represents sun angle. We need to add some points. Each point will represent specific time. The first point will be for the start of a day. Let's change its x-axis value to 0. The second point will be for the end of a day. Let's change its x-axis value to 24. Now let's press F key to zoom out. Here we need to add 3 more points. The first one for 6 AM, the second for 12 PM, and third for 18 PM. Change the x-axis value to proper values. Now we need to set sun angle values for each point. Let's head back to our level and in World Outliner select Directional Light. Default value for sun rotation is minus 46 degrees. Let's change it to 90. As you can see, our lighting has changed. 90 degrees represents the start of day. If we change this value to 180, we'll get 6 in the morning, 270 afternoon, 360 our sunset, and 50 our midnight. Now let's set these values to our day length curve. Press F key to zoom out. As you can see from the look of our curve, each part of a day lasts the same amount of time. We can manipulate with the values on our curve to make our day last longer and our night last shorter. But for now, we'll go with this setup. Now we can go back to our weather system blueprint and create our cycles logic. For this, we need to set some variables. The first one, our current time. Change its type to float. Make sure to check instance editable. Next, day length in minutes, so we can adjust how long will our day last. Also check instance editable. Now let's compile and set the default values. For our current time, it will be 6 in the morning, and for our day length in minutes, for example, 2 minutes. Compile and save. Next, we need to drag and drop our sun, skylight, sky atmosphere and fog to the construction script. Now search for is valid node. Choose the one with question mark. Duplicate it 3 times. Connect each node. Now let's clean the mess. This kind of logic will prevent our game from spamming errors in case we forget to provide a reference to our variables. The next part of logic is for those who prefer control over chaos. It's up to you to follow it or not. I'm gonna make weather system blueprint to inherit world origin's position. What it means? When I drag and drop weather system to the scene, it will always relocate to the world origin position. We need the following nodes. The first one is get world origin location. Second, set actor location. Now, to keep our blueprint less confusing and more cleaner, we need to move our relocation logic before our validation logic. Like this. Now, let's make our sun move. First of all, we need to create another variable which will be the reference for our day length curve. Change type to curve float. Compile and provide our day length curve as a reference. Next, drag and drop day length curve, current time, and sun variables to the construction script. Next, search for set actor rotation. Next, pull a wire from day length curve and search for get float value. Next, we'll need to make a rotator. Search for make rotator. Connect our return value from get float value node with Y field of make rotator. And connect everything. Realign as you like. Now we can test how it works in our level. Go back to our level, drag and drop weather system to the viewport, provide real world actors as our references, and we can play. Now let's change our time. Let's change it one more time. Everything works fine. Let's continue. Now we have seen how our system works in static state. Next step is to update our sun in the real time. For this, head back to our weather system and from the construction script, copy block of nodes about sun rotation. Open our event graph and paste it here. Next, search for event begin play. This event fires only once when the game starts. Now, let's calculate how much time it exactly takes for our sun to make the full cycle. Let's create a variable and call it 1 hour. Change type to float. Next, drag and drop day length in minutes. Then pull a wire and search for multiply. It's an asterisk sign. Float multiplies float. Set the value to 60. Now we have 1 day. Then pull a wire from the result and search for divide. Float divides float. Set the value to 24. Now we have 1 day. Next, drag and drop 1 hour and choose Set 1 hour. Combine the nodes. Now search for tick event. Then pull a wire from delta seconds and search for save divide. Next, get our 1 hour variable and connect it to the B field of save divide node. Next, from the result of the division, pull a wire and search for add. Float adds float. Here we need to connect our current time. As you know, the day lasts for 24 hours. So, if we keep accumulating our time, this value will expand to 24. We need to clamp this value. For this, we need to create 2 branches to check the conditions. You can use a shortcut. It's B plus left mouse click. Like this. Like this. The first condition is if our value is more than 0. If it's true, here comes another condition. Now, the second condition is if our value is less or equals 24. Let's see. If you have true, it means that we are between 0 and 24. So, just set our current time and connect the result of our adding to our variable. In case we have false, that means that we are out of bounds. For this, search for float, subtract float. For A, go with 24. For B field, go with the result of our adding. Now it's a tricky part. This value can be negative, so to prevent this situation, search for absolute. And let's duplicate set current time node and connect it to our apps. We are almost done. We just need to connect the rest of nodes. Now, don't forget to compile, and we can test our day-night cycle in-game. Go back to our level. Make sure you have selected weather system in the world outliner. Look for day length in minutes and set this value to something small, for example 0.5. That means that our day cycle will last for 30 seconds. Let's check it. Sunrise, afternoon, and sunset. Now it's night, and somewhere here we should see another sunrise. Yep. Well, I think we can stop here. We have created a basic day and night cycle, which works pretty well. And in the next video, we will continue developing our weather system. We will add some visual effects, such as rain, snow, fog components, and some lighting adjustments. Thanks for watching. Leave a comment. Don't forget to click like button and make sure to subscribe.